What if tomorrow morning you woke up, looked up at the sky, and the sun was gone? But it didn't just vanish. It was replaced by a black hole, no light, no warmth. Just a pitch-black void, sitting right where our sun used to shine. Would the Earth get sucked in instantly? Would we freeze to death? Would the planets spiral out of control? And how long could humanity survive this cosmic disaster? Let us dive into the terrifying but fascinating scenario of what would happen if a black hole replaced our sun. First, let's clarify one thing. We're not talking about a supermassive black hole here. We're replacing our sun with a stellar mass black hole of equal mass, about 1 solar mass. That's key, because surprisingly, Earth would not get sucked in right away. Wait, what? It sounds strange, but black holes don't magically suck everything like a cosmic vacuum. They obey gravity just like everything else. Since the new black hole would have the same mass as the sun, the gravitational pull on the planets would be the same. Earth's orbit? Still intact. Mercury to Neptune? Still going around? Nothing. But here's the catch. The light is gone. Instantly. The sun is a giant fusion reactor, blasting photons across the solar system. A black hole, on the other hand, emits no light. No energy, no warmth, just darkness. 8 minutes after the switch, Earth would plunge into total darkness. The sky would go pitch black. Solar panels, dead. Photosynthesis, done. You could still see stars, sure. But where the sun once blazed in the sky, there's now a dark void. It wouldn't look like a gaping hole, though. Instead, you'd see a bizarre distortion, a warped shimmer of background stars, bent by the black hole's immense gravity. That's gravitational lensing. Let's talk about temperature. Without sunlight, Earth's surface would start cooling almost immediately, within a week. Average temperatures could drop below -17 degrees Celsius. Within a year, -73 degrees Celsius. Oceans would begin to freeze from the top down, trapping what little heat remains below. Only deep-sea life near hydrothermal vents might survive. The surface would become a frozen wasteland, and we're not even a year in. Could we survive? Maybe. For a while. Governments might build underground cities, powered by nuclear or geothermal energy. Greenhouses with artificial lights could grow food. But the energy cost? Insane. Eventually, resources would run out. Entire ecosystems would collapse. Within a few decades, human civilization as we know it would be over. But what if we got lucky? What if Earth drifted into a new stable orbit around the black hole as accretion disk, the glowing ring of superheated gas some black holes form? Well, that could generate radiation and heat. But it's a stretch. Our black hole swap wasn't violent. It replaced the sun quietly, so no disk would form. Just a silent shadow. Mercury and Venus, same fate. No heat equals no atmosphere equals frozen rocks. Mars, already cold, would become even colder. Jupiter and Saturn. They might retain some internal heat due to their massive sizes, but their moons would freeze too. The entire solar system would turn into a graveyard of ice. Even Pluto, on the outskirts, would drift in frozen silence, now orbiting a ghost. But is that it? Total darkness? Then death? What about other cosmic threats? Could the black hole become unstable? Could Earth's orbit wobble or decay? What if we got too close? What would it actually feel like to be pulled into a black hole? Hold that thought. We're just getting started. Now, let us talk about what happens after those 8 precious minutes run out, after the last rays of sunlight ever to grace Earth fade into blackness. When the black hole takes the sun's place, its light disappears instantly, but Earth still moves forward for 8 minutes, clueless. Then, darkness. Not a gentle twilight, but a curtain-drop blackout. Temperatures nosedive, dropping as much as 6 degrees Celsius per week. Within a year, the Earth's average surface temperature would plummet to -73 degrees Celsius. Yes, the atmosphere offers a little insulation, but without the sun, photosynthesis ends. Plants begin to die within days, animals within weeks. The food chain collapses. But that's just the warm-up act. You see, the sun keeps us in orbit, not because it's warm and bright, but because it's massive. Replace it with a black hole of equal mass, and Earth's orbit would surprisingly stay the same for a while. Because gravity doesn't care about what's emitting light, just about mass and distance. But here's the catch. Black holes don't exist in a vacuum. They devour. They distort. They radiate intense X-rays and gamma rays through the accretion of nearby matter. Our solar system is now gravitationally quiet, but dust, comets, or even gas giants like Jupiter could slowly spiral it over millennia. And when that happens, the black hole could become active, flaring with deadly radiation. Even worse, tidal forces. If Earth got even a bit closer drawn toward the event. Horizon we experience spaghettification, a real term for being stretched like noodles by tidal gravity. You wouldn't fall into the black hole, you'd be pulled apart atom by atom. Let that sink in. Would humanity die out instantly? Not quite. Some life would persist. Humans might survive temporarily in underground bunkers or deep-sea geothermal habitats. We'd rely on nuclear energy, geothermal heat, and artificial lighting to keep basic life support systems running. Entire cities could be built beneath the surface, but food production? That becomes the biggest crisis. Without sunlight, there are no crops. We have to turn to hydroponics, fungi, or lab-grown meat, all powered by energy sources we currently don't have enough of. Would it be sustainable? Only if we plan ahead. This isn't a catastrophe we could recover from in decades or even centuries. It's permanent. Black holes aren't just masses of darkness. If this one had spin or charge, it could warp space-time, dragging it along like water around a drain. That means time dilation near the black hole clocks ticking slower the closer you get. Would we see stars bend around it? Absolutely. Through gravitational lensing, you'd witness twisted constellations, ring-like distortions, and celestial mirages that defy logic. Imagine looking up and seeing a perfect circle of light, the eerie silhouette of the black hole warping reality around it. Terrifying? Yes. Beautiful? Also yes. But definitely not survivable. Planets like Mars or Jupiter, still orbiting at first. But with no solar wind to protect them, their atmospheres may evaporate or collapse. Moons with subsurface oceans like Europa or Enceladus could become humanity's last hope if we ever get off this frozen Earth. But don't count on that journey being easy. No sun means no solar energy for propulsion, no easy navigation, and a much colder space. Deep space exploration becomes a matter of desperation, not ambition. Over time, the planets may drift, pulled by the black hole or disturbed by passing stars. The black hole may begin collecting matter, growing larger and more dangerous. Without the sun, the solar system becomes silent. No day, no night. Just darkness, a frozen Earth orbiting a cosmic monster, a tomb circling a ghost. So what if a black hole replaced our sun? We wouldn't be vaporized instantly, but our world would become a cold, lightless graveyard. Life would struggle, adapt, or vanish. Earth would float in eternal night, locked in a gravitational embrace with a star that no longer shines but consumes. Still think black holes are just cool space stuff? Yeah, they are, but they're also terrifying. Now here's the real question. What if we could create black holes on Earth? Or, what if you were falling into one right now? Let us know your wildest space questions in the comments, and don't forget to like, subscribe, and ignite your curiosity every week with us. Or, because in this universe, the questions are infinite. And the answers? They're stranger than fiction.